Routing algorithm. As the name implies, routing. So we need to find a route to transfer the packet from the source to the destination. So here in this example, in the image, we have the source computer, we have the destination computer. So A source is trying to send a packet to the destination computer. This A source is connected to the first router. Now the packet is standing in the first router, and now the router thinks of that through which route we can transfer this packet to the destination, because this first router is connected to the router 2, router 3 and router 4. So we have three different routes to transfer the packet from the source computer to the destination computer. So here the confusion is through which link or through which router we are going to transfer, or we need to transfer the packet to the destination computer. Let me see how this transfer of packets can take place from the source computer to the destination computer. So here we see like a number of nodes which are connected with many devices. So likewise, all around the world, all the computers, all the devices are connected to the internet. So how we are going to transfer the data from one system to the other system? That is what we are going to see in this routing algorithm techniques. So what this routing means? So as the example here I've given, like here we have like 5 different nodes, and all these nodes are being interconnected with n number of routers in the network. For example, this node A can transfer to node C through any routers. For example, this A is connected to the router 1. So router 1 can connected to router 3, router 4 and router 2 in direct connections. So I can transfer the data from the device A to device C through router 1, router 2 directly, or router 1, router 3, router 4, router 2 directly, or router 1, router 3, router 5, router 6, router 2 to the device C. So there are n number of ways to transfer the data from the device A to the device C. The another example here I've shown, this is like a very well understood by all the people. So here for example, presently I'm standing in the SRM college, which is in Ramapuram campus. Now I would like to travel to the central stations. So if I find the map, if I put the map to travel from the SRM Ramapuram campus to the central railway station, I could find like 3 different routes. So this is the blue color route which is highlighted. I have chosen this respective track. We have like 2 more routes. So this is one of the route, and these routes also can be divided into 2 different routes. So you can also find that what is the time taken by the respective route, and what is the distance I'm going to have between the starting point and the ending point. For example, in this map, I have like 3 different routes. Let me see this route now. So in this blue color highlighted route, where I have like a 16.1 kilometer distance, but the traveling time is only 48 minutes. If I choose this ash color track where I have like a little bit of a traffic, it is also having like a 46 minutes, same the kilometer of 16 kilometer. So if I see these 2 routes, it is having like a 16.1 and 16. So both the kilometers are same, but see the traveling time period. So in this route I could see only 46 minutes, whereas in this routes I could see like 48 minutes. So from these 2 routes, which route will you prefer to travel from SRM Ramapuram campus to Chennai Central Railway Station? Where I have the lowest kilometer and the lowest time period. So through that route only you are planning to travel your route. So likewise only in our topic also, among the n number of routers, we are going to choose through which link we are going to transfer the packet from the source to the destinations. So let me see in detail in the upcoming slides. Right, now we are going to see like what are the types of routing. Okay, so the routing are divided into intra-domain and inter-domain. So now we are going to see about the intra-domain first. So this intra-domain are divided into distance vector as well as link state, whereas this inter-domain is divided into the path vectors. But again, this distance vector is going to give a more information about RIP. What is RIP? RIP is nothing but routing information protocol, and OSPF is nothing but open shortest path first. And the last one is BGP, which is nothing but a broader gateway protocol. So now in this PPT, we are going to see about the distance vector under intra-domain. So intra-domain in the sense like we are going to have the internally about all the communications now. Now, so here I have like many peoples are there. All the peoples are interconnected with a link. Okay, for example, this person is being connected to all the person who are there in the network. So all the persons are trying to transfer the information about themselves. So whom are there and with whom, what are the devices are being connected. Now let me see here. So all the persons who are there in the network are trying to share the information about them to the other persons in the network. So what we have to do here is between the source and the destination, we are going to have like many number of routers in the networks. So every router are supposed to update about their information to their nearby neighbors. So that is the first objective we are going to see in our distance vector. So here what we're going to do, all the router are supposed to update about their information to the nearby neighbors. So from this figure, we should have in mind that so all the routers which are there in the internet world are supposed to share about their information to the nearby neighbors. That is, what is their name, what is the time taken, and what is the distance is going to be. So likewise, all the information about the respective router should be shared to the nearby neighbors. Right. So as the name implies, distance vector routing. So what does it mean? Every router in the network are supposed to share their information to their immediate neighbors periodically. So every time the router, for example, every 5 minutes or every half an hour or every 1 hour. So this information about the routing table are supposed to share the information to the nearby neighbors periodically. And this has to be done. Why we are going to do this periodical updation? So that we are going to have a transfer the packet from the source to the destinations. We should have the complete information about your network so that you can choose which is the best route to transfer the data from the source to the destinations. So what is the first objective we are supposed to think of here? Every router supposed to update their information to their immediate neighbors in periodically. That is every 5 minutes once or every 1 hour once. Okay. So what we supposed to have some point, right? So as I said, we have seen in the previous figure that many number of routers are there. Some routers are very nearby, some routers are very far away. But I would like to transfer the information from the first node to the person who is standing very far away. But if I shout from my places to the last person, my voice is not audible to the last person. So what I'm trying to do, I'm going to take a piece of paper. I'm going to write the small information that what I want to convey from the source to the destination. And I'm going to convey this information to the person who's standing nearby me. It can be X name or a Y name. So I'm trying to transfer this piece of a paper to the person who's standing nearby me, and he is going to transfer the paper to the next person who's been connected to the X person. So likewise, this piece of a paper has been transferring from the person to person, person to person. Finally, it is going to reach to my destinations. So how many number of persons this paper has been transferred? That is nothing but the distance. Okay. So first point is nothing but in distance vector routing, each node they're going to create their own least cost tree, which with the rudimentary information about it to the immediate neighbors, which means least cost in the sense that is the distance between the first person, that is a source, and the nearby neighbors who are going to be get connected. So we have to find what is the route or what is the distance between the source and the two nearby neighbors who have been connected. And I'm going to share all this information to my nearby neighbors. That is what the first objective which I said here. All the information about the source which should be transferred to the nearby router X as well as the router Y. So by transferring only, this information will be keep on transferring from one router to the other router, one router to the other router. So the entire information, what is going to happen in my network, I could have a clear idea. So everybody in the internet are supposed to transfer the informations about the nearby neighbors to the all the persons. Right. So as we seen in the previous example, like I'm the source, nearby me I could see only like two persons are standing. Yes or no? So I know the clear information who are standing very nearby me, but I don't know the person who is standing very far away. So I don't know what is the distance from the source to the last destinations. Okay, which means that I want to transfer the data, but I could not able to find what is the route, in what way I can transfer this piece of a paper from the source to the destinations. So here the tree becomes incomplete. But I want to find the route first. By knowing the route only, you can start to travel. You can start passing up the piece of a paper from the source through the n number of routers to the destinations. So now we are going to see that how we are going to make a connection from the source to the destinations. Okay. So we are going to frame this connection from the source to the destination with the help of Bellman-Ford equations. What we are going to do here, we are going to find what is the least cost. What does the least cost mean? The least cost is nothing but the shortest distance. So we are going to find the shortest distance between the source and the destinations. So here for an example, we are going to take the source name as X. We are going to call this source as a node X. Similarly, the destination we are going to call it as a node Y. Between the source X and the destination Y, we are going to have like three intermediate nodes, namely A, B and C. So we have the source name as X, we have the destination name as Y, and we are going to have the intermediate link names as A, B as well as C. So we need to find what is the cost, that is the distance between the two hosts. Okay, first we need to find the connection between the source and the intermediary nodes. So this is nothing but one of the cost. So first thing, I'm going to find the distance between the source and the first intermediary nodes. And then finally I'll be having this is C node which is going to be get connected to my node Y. So I need to find the cost as well as the distance between the source to the intermediary and from the intermediary to the destinations. So we are going to find the distance, the best route between the two source and the destination with the help of the Bellman-Ford equation. So this is the given equation. Here we have the least cost which stands with the Cij, and the distance between the two nodes is nothing but Dij. So from this we are going to take the minimum value. As we've seen in the first example, with the map diagram, we have seen like a 16.1 kilometer and 16 kilometer, and we have seen the time period like a 46 minutes and 48 minutes. So out of these two, we are finding the least distance and the least time period. Similarly, we are going to find n number of routes. From the routes, we need to find what is the least cost and what is the minimum distance. So we'll be having like enormous amount of intermediate nodes. Okay, so from the three nodes, we need to find which is the best route. Best route in the sense, the shortest route and the shortest least cost. Okay, so CXA is nothing but the connections between the source and the intermediary nodes. And the D is nothing but the connection, the distance between the source and the intermediary. Okay, now let me see this equation connections in this with a small diagram. Now see here, we have the source name called as X. We have the destination node name as a Y. So in between the two, we are going to have like A, B and C as your intermediary nodes. So the connection made between your X and A, X and Y and X and C, which defines this as least cost, which is as a C. So the distance between X and A is nothing but CXA. The distance between the cost between X and B is nothing but CXB. and the cost between X and C is nothing but CXC. So we are going to define the least cost between the source node as well as the intermediary nodes. And I'm going to find the distance between the intermediary nodes and the destination node. So that is nothing but DAY, DBY, DCY. So from the intermediary node to the destination is nothing but the distance. So among these three routes, we need to find that which is the shortest route and which route is having the least cost. So among these three, we need to find the best route. After finding the best route, so through that route, we are trying to have a travel. So from these three connections, we have made to a single connections now. So we got some single route now, and we're going to define what is the route. So now the simplest route is nothing but CXY. So I'm going to replace all these intermediary nodes as some Z. So the connection between X and Z is nothing but CXZ, which is the least cost, and the distance between the Z and your node Y is nothing but DZY. This is the distance between your X as Z as well as Y, and the total distance between the X and the Y node is something but DXY. So from this three given link, we have find the shortest value among the three. So the shortest value we define as a CXZ plus a DZY is the shortest distance among the three given intermediary nodes. So with this concept, now we are going to see how to choose our track. Okay, so this is how the network is going to be. So among this n number of computer system, we are going to transfer the data from one of the computer who is in some other end to traveling through the network, the router, and through n number of routes and packets. Finally, we are going to reach some destination computers now. Let me see how we are going to transfer this and how we are going to choose the route among the internets. Now, let me have a small example. So before we going into the detailed concept, I'll give a small story about how we are going to transfer the packet from the device A to the device E. So here we have the 5 devices like device A, B, C, D and E, and which is all connected to the router name called R1, R2, R3, R4 and R5. But here for the example, I'm going to transfer the packet between the device A and device E. So I'm going to have a computer which is connected to the router 1, and also have the other computer the destination side which is connected to the router R5. So this is name is called device E is connected to the router R5 and the device A is connected to the router R1. Now the device A generated the data and it's transferring down the packets to the router R1 now. Now the packets are standing in the router R1. Now from the R1 to R5, it is finally like 3 different routes. So R1 to R2 to R5 is nothing but route 1. R1 to R5 we have a direct connection, that is a route 2. R1 to R3 to R4 to R5 we have the other route, that is route 3. But all this among this 3 route, which route we can travel to transfer the packets from the device A to the device E. So first we should know what is the distance which is available between all the routers. So the distance between the router R1 and the router R2 is nothing but, for example, I'm taking now this is like about 2 kilometers. So the distance between R2 and R3 is nothing but 3 kilometers. Similarly, the distance between the router R1 and R5 is nothing but 6 kilometers. So the distance between router R1 and R3 is nothing but 2 kilometers. R3 and R4 is nothing but 3 kilometers. R4 and R5 is nothing but 4 kilometers now. Now we come to know the distance between all the routers now. Now we need to count all the routers. So now as I said, like we have like 3 different routes. So route 1 is nothing but between the router R1, R2 and R5. So this is nothing but route 1. Okay. Next route 2 is nothing but between your R1 and R5. And route 3 is nothing but between your R1, R3, R4 and R5. So we have like 3 different routes. Now how to find through which route we can transfer this packet from the router R1. So now we need to count the values of the distance. For example, this is route 1. We have the kilometers like 2 plus 3. So what is the total count of this? This is nothing but 5 kilometers in the route 1. So in the route 2, we have the only direct connections between R1 and R2 with a kilometer of 6 kilometers. And in the route 3, we have the 3 different links like a 2 kilometer plus 3 kilometers plus 4 kilometer. Totally we're going to have around like a 9 kilometers. Now just calculate the distance. Route 1 is 5 kilometer, route 2 is 6 kilometer, and route 3 is nothing but 9 kilometers now. Now, which is the least value? 5, 6, 9 we have. So, the least value is nothing but 5. So, this is the least distance. This is the shortest distance. So, we are going to choose the route 1 because route 3, which is very longest distance, which is having around like a 9 kilometers, I'm going to discard. Again, the route 2, which is like a 6 kilometer, I'm going to discard. And I'm going to choose the route 1 because they have only a 5 kilometer. So it is very shortest distance. So through that route, if I choose route 1, so the packet will be delivered to the destination E in a very fast manner. Okay. Now, I have like n number of routers. Yes or no? In the route 1, I have like one router. In route 2, I doesn't have any router. From router R1 to R5 is directly connected. Whereas in the route 3, I have like two more routers. So, how many number of routers are placed between the two source and destination? That is nothing but a hopping. For example, if I'm going to travel through the router R1, that is the route R1 is nothing but this is the place where I'm standing. So I should not suppose to take the count where I'm standing now. So from here where I'm going to have a jumping, only that I'm going to have it as a count. Jumping the sense nothing but a hopping. Okay. So from R1 to R5, how many number of jumps I need to travel? So I am supposed to start from R1. My first jumps to R2, my second jump to R5. So how many jumps I've taken? I've taken 2 jumps. This is called as hopping. So 2 hops I've taken in the route 1. In the route 2, we have like from R1 to R5 directly. So here I have like only 1 jump, which is called as hop 1. Whereas in the route 3, I suppose to jump from R1 to R3 is the first jump, R3 to R4 is the second jump, and R4 to R5 is the third jump. So in the route 3, I'll be having like a hopping of 3 number of hopping is going to take place. Now among this, I need to find which is the smallest hopping. So I need to check out the smallest hopping and the least distance. So by verifying these two conditions only, we were going to freeze the connection between the source and the destinations. So what is the concept here? We need to find the best route. What is the best route? The shortest distance and the least cost values. Now we are going into the topic now. Now as of now, I was giving only the examples now. Now with this example in our mind, now we are going into the subject concept now. Okay. So here they have given like 7 different nodes. Okay, with some distances here. So for example, this is called as a tree diagram. Now we are going to talk about the node A because node A is going to act as a source. From node A, I'm going to transfer the data to node G, okay, which is very far away from the distance. So I need to find what are the routes are available to transfer my data to the node G. So first I should find the route now. So if I transfer the data through the node D, I have no link further. So I'm not going to take this path. So I'm going to just find out the route between A to B, B to C. Again from C there is no link. So again it is a breakup. So I'm going to discard. So I'm going to check out the third route. So about A to B, B to E, E to F, and then F to G I have it. So I'm going to transfer the data to the node G through the intermediate nodes like B, E, F, and then to G. So now I need to find the distance between that. How many number of hops I supposed to take up now. So we are going to call this as a node A tree diagram. So this is all connected with the nodes and your links. So we're going to call this as a tree diagram now. Now from A, okay, the A which is connected, direct connections between the node D and node B now. Okay, so I don't know what are the connections are available after beyond the limit of this B. So I'm not aware about that. So what the first step we are going to do is that, so from my source, so what is the source here? The node A. So this node A is going to get the updates from the nearby neighbors. Who are the nearby neighbors? The node B and the node D. So from these two nearby neighbors, the A is going to gather the information that what are the nearby devices are being connected. So A is going to get the updation about the node B and the node D. So by this updation, we are going to find what is the distance now. Okay. So now how many number of nodes are there? We have like around 7 different nodes. But where we're going to transfer the data? From the device A to device G now. So to transfer this, we need to find what is the distance. Okay. First, I'm going to transfer the data within the node itself. That is, I'm going to start from A, ending at A itself. Start from A, ending at A itself. So what is the distance? The distance value is nothing but 0. So the A to A is nothing but the distance value is 0 now. Now I'm going to transfer the data from A to B. I'm going to transfer the data from A to B. So to transfer the distance is nothing but the value is 2. So the distance between your A and the B is nothing but 2 here. So what happened? The distance between the A and B is nothing but the value is 2. Next, if I see the distance between A and D is nothing but 3. Now see here, the distance between A and D, the value is nothing but 3. And next is between your B and C. Between your B and C is nothing but I'm going to have the distance of around like a 7. So between your between your A and C, the distance is nothing but C. So likewise, all the values are being updated. So with the node of A only, we are going to compare all the distance. So up to G9, for example, A to G9 is nothing but the distance is nothing but 9. So likewise, every node, we're going to call all this as a router. Okay, now all the router in the tree are going to give the distance vector. So every router, like a router A, router B, router C, router E, router G, every router are going to prepare the vector diagram by their own. Okay, see here now. So here all the vector, all the nodes, okay, all the nodes, they have prepared their own diagram now. Let me have one more time here. So A, the distance between your A and B is nothing but 2. Okay, so first we have to check out the nearby neighbors now. Now A is connected with the D device as well as the B device, that is the router. Okay, first I have to check out. So here I'm listed out all the number of router which are available in the network now. So starting from A up to G, all the routers are been listed out here. So I need to find the distance between the standing node and the remaining nodes. So the distance between A to A is nothing but 0. If I want to transfer the data from A to B, what is the distance here? A to B distance is nothing but 2. So here the distance is updated as a 2 now. And A to D have a connection. So A to D connection is nothing but 3. So A to D, the distance value is nothing but 3 now here. So whereas the C, E, F and G are not connected directly to the device A. Okay, so whichever router are not having a direct connection to the router A, we are going to give this as infinity. Infinity in the sense I cannot able to define. I don't know how long the distance the device C, device E, F and G are available. So router A, it's defining about himself that only the device B and device D are connected to nearby. I know what is the distance between A and B and A and D, but I don't know about the connections of the router C, router E, router F and router G. Likewise, first step is nothing but every router are going to update about their own information in the respective distance vector. Now this is nothing but it is only about B now. Now for example, now B is having a direct link between the node A, node E as well as node C now. So and between the B is nothing but 0. So what happened now? Now A to B to A, the distance is nothing but 2. So see here for the A it has been updated as a 2. Within B is nothing but 0. And B to C have a connection value as a 5. Between B and E have the value as a 4. But this D, F and E, I don't have a direct connections with the B node. So I'm going to mention this as an infinity. Infinity means I don't know about the idea. I don't know what is the distance between the B and the other node which is very far away. So likewise, all the router are updated about their own information. So now every router are having their own information now. That is first step. Now what is the second step we have to do? We have to share all the information about yourself to the nearby neighbors first. Okay, that is the next step we are going to do now. Okay, so these rudimentary vectors cannot help the internet because from the previous step, every router have their own information now. Right, every router are having their own information now. If you're not going to share your information about you to your nearby neighbor, then nobody knows about you, where you're standing and what is your distance now. So without knowing about you to the nearby neighbors, nobody will transfer the data from them to you. Okay, so we cannot make a connections in the internet world then. So to improve your connections in order to develop your tree network in the internet, we supposed to transfer the information about you to the nearby neighbors. That's very, very important. So we have to give a exchanging about your information to the nearby routers. Okay, you're going to share about your copy of your vector to the immediate nearby vectors. After sharing about these things, we are going to get the information about your friend also to you. So you're going to tell what is your name to your friend, and similarly you're going to get what is your name likewise. So what is your phone number, what is your address, where you're coming from. Likewise, you're going to get all the information from your nearby neighbors, and you're going to get updated in your table also. So you're going to save your friend's phone number. Okay, nearby me the route device D is there, so I'm going to note on what is a phone number, what is a mail ID, and what is a door number. So likewise, you're going to get update about them in your distance vector table also. So all this process are done with the help of Bellman-Ford equations. Okay, so least cost is nothing, but you're not going to update only about the person who is standing nearby. We supposed to get the information about n number of routers. As we seen in the example, like there are around like 7 routers. So every device should know the information about the remaining 6 routers. By knowing only, you can able to find through which route you're going to transfer your packets. Let me see with an example again now. Okay, so now A node is going to act as a source now. Now from A, we're going to transfer a data to the device B now. Yes or no? So the B device are supposed to get updated now. Since A is your source, A is going to be as such now. So now you are going to do the updation in the upcoming routes. So first A is connected to the node B now. So this is my old value of your node. This is the node value of A. This is the old value of a node now. Now see the formula for the Bellman-Ford is nothing but B, because now we are going to find what is the new vector table of B now. The minimum of B of that respective number, comma 2 plus AI. What is this 2? Because the distance between the A and B is nothing but 2. The distance between A and B is nothing but 2. For example, let me see the previous diagram. Now see here, the distance between A and B is nothing but 2. So if we want to travel from the node A to node B, it takes 2 minutes of time period, or you have to travel for a 2 kilometer. So whenever you're going to travel from A to B, you take 2 minutes of time period to travel. So all the values are going to be get added, plus 2 plus 2 plus 2 based upon the distance value. Okay, so now we are going to update our vector table of the device B now here. Okay, so we need to find plus 2. Okay, so B value is here. With the B value, we are going to add plus 2, but after adding, we need to find what is the minimum value. That minimum value should be retained in your distance vector, and we are going to remove we are going to neglect your maximum values. That is the highest values now, because what is the form it has been given here in the Bell formula, like a minimum. Okay, now this is my old value now. Now first value is something but 2. Right, first value is something but 2, that is your B value, plus, okay, 2 plus A values. 2 plus A value. So what happened here? This is 2. This is also 2. Old value of A is 2, and your B value of A plus, that is a 0 plus 2, the respective value is also 2. So from this 2 comma 2, which is the lowest value? 2 is the lowest value. So that is being taken into my new table. And now we are coming to the second one. So here I have 0. In A I have 2 now. So with A only we are going to add the value of plus 2. So here the plus 2 becomes the value as a 4. Okay, so now we are going to compare your old B value with the new B values. So now this is 0, this is 4 now, which is the minimum value. 0 is a minimum value, so that is updated in your new B distance vector. Now the third value is nothing but 5, and with this C value is nothing but infinity. So any value addition to infinity is going to be your infinity. So we are going to compare now this is 5 with infinity, which is the smallest value. 5 is your smallest value, so that is updated in my new B. And now we are going to compare the D values. Now this is infinity and this is 3 now. Okay, so with this 3 we are going to add plus 2 as per the formula. So 3 plus 2 is nothing but 5 now. Now infinity I have, this side I have a 5, which is the smallest value among these two. 5 is the smallest value, so that is updated in my B table now. Now next is value something by 4 plus infinity. So 4 plus 2 is now also has been infinity. So among these two value, 4 is the smallest value. So 4 has been updated. So these two are infinity, infinity. So I've taken as an infinity now. So now the vector of node A is compared with the vector of node B now. So now the depending upon the vector of the two nodes, that is A and B, new vector has been framed now. Now this is the updated vector which is going to available in the node A. Node B now. Likewise, what is the next route I'm going to have? I'm going to have the next route from the device B to device E now. Okay, so we need to find what is the distance between the device B and device E, because from the B, because I have the route like A, B, E, F and then G, I'm going to have a transfer for examples now. So this B table has been updated with the help of the device A. Now what is the next device which I'm going to get updated? About E now. The distance between your B node and E node is nothing but 4. So I'm going to take that respective distance as my addition. So see here now, the minimum value of B, comma 4 plus E. The distance between your B node and your E node is nothing but 4. So this is going to be get added with my E vector table now. This is my old B. What is my old B? This is my old B now. Yes or no? So now with this newly updated table, we're going to compare the newly updated table with the node E now. So likewise, your table will keep on updating. Every time, as we have seen that your vector table is supposed to get updated periodically. That is the word very important. Every time whenever you're going to get the information from your nearby router, you have to get updated. Okay. So now we are going to compare by the same way with the old B with your E vectors now. So now all with your E node vectors, we are going to add with the value of 4. Again, by seeing the two value, we are going to update all the things to the new value, which is the minimum value. Now this is my new B vectors. Likewise, every vector table are going to be get updated in the tree networks. Okay. Now next concept is nothing but count to infinity. What is count to infinity? As we've seen that we have to keep in our mind like two important points, the shortest distance and the least cost. The first point is nothing but any decrease in the cost. If suppose you come to know that if there is any decrease in the cost, yes, that is really a good news, because by decreasing cost route only, I'm going to transfer my data in a very fast manner. So I'm going to have the propagation in a very quick manner. The second point is nothing but if there is an increase in your cost, if there is an increase in cost, it is going to take more value. So that is a bad news for us, because where the propagation will be very slow process. If there is a decrease in cost, I'll be having faster propagation. If there is an increase in cost, I'll be having a very slow propagation. When they are talking about a two connection, but the third case is nothing but if suppose the connection between the two routers is going to get broken. If there is no link between the respective router, then we cannot able to get updation by the nearby neighbor, because I don't have the link. If I have a link only, you're going to get the updation through that link. If there is no link between the two nodes, means you cannot get any updation. In that cases, you're going to define your respective distance value as infinity. because we can have the number of maximum hoppers only as a 15. If it is more than 15, we are going to call that number value as an infinity. So from 1 to 15 only, we are going to have the number of hops. If it is more than 15, for example, it is a 16 or a 17, we are going to define that respective value as an infinity. Okay, so all this information are supposed to get updated in your respective vector table immediately. Whenever you're going to get the information, that's supposed to be updated immediately. So what does now count to infinity means? Count to infinity is nothing but it is sometimes take several updates before the cost for broken line is recorded as the infinity by the router. For example, now I am the source, my name is A. So I have like two nearby neighbors, like a neighbor B and neighbor C. Okay. So now by mistakenly, the link between the node A and node B become broken. So what happened as a node A, I'm going to update about the node B that there is no connection between A and B. So I'm going to define the value, the distance value as an infinity. Okay, and this information supposed to be shared to my another nearby neighbor is nothing but C, so that the C also will get update that okay, there is no connection between the node A and node B, so I should not supposed to make a connection or the transfer of packet through node A to the node B. So this information supposed to be get updated in all the router, so that every router comes to know that okay, the device B is being removed from the network. So we not supposed to transfer any data from any of the router to the device or to the router B. Okay, so this is called as a infinity. Infinity in the sense there is no connection between that respective routers. Now we will go for the small example about the concept of this count to infinity. Here we are going to take only two nodes, that is the node A and node B, but we are going to have like one more connections, that is device X is connected only to the router of A. So the router name is nothing but A and this router name is nothing but B, and we have like two networks. So this box represents a network. Okay, so this X network is connected to only to the router router A. Okay, let me check out the distance now. So we have like a router A and router B. Okay, if you want to travel from this router B to the device X, how many number of jump I supposed to take? This is from here to here, that is, this is jump 1, this is jump 2. So I'm going to take the number of hops as a 2. From here means, from here I'm going to jump directly to the X, so I have only the jump value as a 1. That is, the hop value is nothing but 1. And this X stands for the destination address. This X stands as the destination address. So here the device is connected, device X is being connected to the router A. And now in this case scenario, the B router would like to transfer the packet from the router B to the router, to the device X through the router A. Okay, but by mistakenly, what happens? The link between the node, the router A and the device X been broken. Okay, so the router A comes to knows that okay, the connection between the router A and the device X is been broken. So this is updating himself that there is no connection between the router A and the device X. If there is no connection, what is the value we are supposed to update? This is as infinity. Infinity means this is the longest distance. So the distance is very, very far away. So I'm going to give a value. I'm going to update my connection value between the router A and your X value as an infinity. So infinity means what I said, if it is more than 15. So here I've given the value as a 16, which means that this is infinity. So there is no connection between the router A and the device X. So router A updated himself that there is no connection between the device X. So what the router have to do now? This information supposed to be transferred to all the routers who are nearby in the neighbors and also the entire tree of the internets. But if he doesn't transfer this information to the nearby neighbor, what the other people will think of? If suppose the other people like the device B wants to transfer a data to the device X, it will try to transfer, because the device B doesn't come to know that okay, there's a connection between the device A and the router A and the device B. Let me transfer the data. If there's a connection is broken, means we supposed to update that respective information to all the router who are there in the tree. Okay, if we didn't apply, that's a problem which is going to be facing now. Let me see the problem what is going to take place now. So the router A updated its distance vector table now, but before transmission of this routing that is the vector table to the device B, the device router B started transferring the data to the router A. Okay, in the previous cases there is a broken link. This broken link is updated in the router table of A, but this information is not delivered to the router B. Before delivering of this vector table, the router B trying to transfer the data to the device X through the router A now. Okay, now the router A is receiving a packet from the router B. Okay, since router A is receiving a packet, it is assuming that okay, I'm getting some new information from the router B. So now the router A is trying to update its information about the router B. Okay, now the router A sent its new after updating the respective router of the router A. It is trying to transfer the updated information about the router A to the router B now. Okay, so what is the information here? We have like about 2. The router B is nothing but 2. When we are transferring this information to the router A, it is adding +1. So now the table of the vector table of router A becomes 3 now. Now again this updated information is transferring from the router A to the router B now. So here we have like the value as a 2. Now when we're going to have the transfer of the data, it is going to have the hopping value as a 3. Because here we are transferring the value as a 3. Again +1 takes place here. So now this value become 4 now. So what happened now? This is keep on transferring front and back, front and back, front and back now. What is actually the problem? A thinks of that there is a connection which is known by B. So A thinks of that okay, there is a connection between B and X. So we can transfer the data to the B now. When B is receiving a packet from the device A, B thinks of that okay, there is a connection between A and X. Okay, let me transfer the packet to the A itself. So likewise, the packet is bombarding between the router of A and B. So what happened now? This packet is not finally delivered to the device X because the device X is broken from the tree. Now this value is updated in the distance vector table as infinity, because this packet is keep on bombarding between the two routers of router A and router B. Okay, so this is the problem here now. Okay, this is the problem now. Now how we can rectify this? Okay, so here the concept is like the cost of reaching X increases gradually. Yes or no? I could not be able to reach the device X, and the packet is keep on bombarding between the A and B, A and B, A and B. A is pushing the packet to B and B is pushing the packet to A. Likewise, keep on bombarding. Yes or no? So while bombarding, what happened? The value of your respective distance become infinity. Okay, so what happened now? This systems become unstable. So this instability of the system can be improved by the concept called split horizon. What does a split horizon means? First thing is that I am the source. I have my two nearby friends now. As we seen in the first example, whenever I'm getting any information, for example, I have a connection to the device A, the router A and router B. I'm the source, so I'll take my name as a yes. Okay, so by mistakenly the router A link has been broken. Okay, the router A link has been broken, so there is no connection between the router S, that is the device S, and the router A. I supposed to update this information myself. In my table, I supposed to update that there is no connection between S and A. So I'm going to make the distance value as infinity. and this supposed to be transferred immediately to my nearby neighbors. So what happened now? I supposed to keep on updating my table, and this information which is updated by myself are supposed to transfer it to all the routers who are there in the internet world. So what happened now? Updation, modifying, updation, sending, modifying, updation, sending, modifying, updation, sending. So all time the router keep on getting updations sending. So they become as a great confusion. What I have to do, man? You keep on sending the modification, you keep on sending the updation. What is happening in the network? So the router are getting some confusions. So to avoid such kind of confusions, what we are going to do is that in order to maintain the stability of the system, we are going to eliminate the last point. Okay, we are going to eliminate the last row value. Instead of updating the entire information, let me remove the last values and we will update only the partial information about the respective router to the nearby neighbor of the respective router, so that the first updation whatever we are going to get, that has been updated in the respective vector tables. Okay, so this is the concept of distance vector routing. Thank you.